All right. Well, my name is Pat Harris. I'm a senior network engineer for U.S. Sugar Corporation. And I'm an end user. I'm not a distributor or a supplier or a trainer or anything. And we had the opportunity several years ago, 2011, to really do an interesting project with Mikrotik. And we've been really happy with it. And I'm all excited about it. And I believe a lot in Mikrotik. So I wanted to do this presentation. I did this presentation in Zagreb, Croatia in 2012. This one's a little bit of a modification to it. I stay pretty high level. I'm not going to go deep diving into things. And I do have an extensive presentation because I had a 30-minute window to complete this one that I will gladly share with anyone, after this. I have it on thumb drive so we can just copy it over to whatever you want, or I'll email it to you, a copy of it gladly. And I'm also going to upload that full presentation to the Mikrotik for them to place on their site. Anyway, again, Pat Harris, Senior Network Engineer for United States Sugar Corporation. I'm going to go through a little bit about the company. We're headquartered in Clewiston, Florida. We farm about 180,000 plus acres, and we have a state-of-the-art nursery where we do research in citrus up in North Florida. We're the largest vertically integrated producer of sugar cane and refined cane sugar in the U.S. And we have a subsidiary company, Southern Garden Citrus. That's one of the major growers of oranges and processors of orange juice products. Florida. And in the season, we process up to 42,000 tons of sugar cane a day and produce more or less 750,000 tons of refined sugar per year. This project in 2010/11 was identified as an operational excellence program because of the land holdings and because of the need to become globally competitive in this market. We needed to identify some capabilities of automated cultivation, and that's really what this whole thing revolved around, was the ability to automate our cultivation processes. And we found a great deal of other uses for it as well, as I'll try and cover briefly as we go on. But so what happened was we explored, opportunities, cellular connectivity, which was immediately ruled out. There was no coverage in some of the southern areas of our land, and the carriers couldn't support the amount of connectivity we were ultimately going to require, because any time we could possibly have around 1,000 pieces of equipment. Now, concurrently, there may be 200 to 300 actually actively utilizing the system through any given time, but it's possible to go as high as 1,000. So they didn't have the capabilities. WiMAX, there were not just client compatibility issues, but costs involved with a WiMAX deployment, which rendered a return on investment unachievable. So that was pretty much ruled out. So the chosen solution was to build a private wireless wide area network based upon the 802.11 standard. And to qualify a few things, we have advantages that a lot of other people don't have. We do control all of this land. We have some communities that border our land, but predominantly the vast amount of our land is controlled by us. Structurally, there's not much out there as far as building goes. From a topography standpoint, you're in Florida. And you'll have to excuse me for this accent. Ever since I came to Miami, this happened to me. I don't know what's going on. But, yeah, forgive me for that. And so anyway, so ultimately we decided upon an 802.11 solution, and it basically combined the utilization of existing facilities that we own and the installation of combination of towers ranging in the neighborhood of 120 feet to 140 feet, and then 50 feet for some lull areas to fill in darker areas. Some of the challenges we faced and the considerations with the design of this were, and these were input from our agricultural department as well as other end users and department heads as we met to develop this. Some of the requirements: direct client access, system-wide roaming. Of course, the system has to scale. Redundancy wherever possible. because it has to run. This is a 24-hour-a-day, 7-day-a-week operation, especially during our grind, what we call the grind or harvest season. But we refine and process and package and ship sugar year-round. So, and enterprise security options compatible with a diverse array of client systems, performance, cost, ease of maintenance, ease of installation, availability of components. Man, between Aruba and just looking at every other vendor and what it would take to actually compile a system like this, Mikrotik is able to do like just all of this, and they were hands down the right choice for the solution to this system. An important note, and something that almost got me when considering to build a system like this and review of your hardware, is the hardware's capabilities. And because the system did ultimately become an MPLS and VPLS based system, you have certain impact on your frames. And you're adding, 4 bytes, 4 bytes, 4 bytes. Well, if you look at the hardware, which I put a link down here to it on the slide, certain hardware platforms have limitations that I got lucky on that one. But it would be better to review those things ahead of time and be aware walking in with eyes open, and instead of saying, oh man, I slid under the wire on that one. But anyway, that is important. A recommendation, going ahead for it, and something that I've always found beneficial is to try and normalize your router OS as much as possible. You don't want to fight a bug on this version and then all of a sudden you're fighting a different bug on another version. If you've got a platform that's pretty uniform across the board, any issues you run into, you're gonna probably solve them across the board, or you're gonna solve them faster. It's just gonna help you out a lot. Troubleshooting, support, everything. Oh, and we are on 627. It's flawless. I have no issues with it. I mean, sorry if y'all do, but I don't. It runs great. Have no problems. Other tips, the system building blocks going in, set your boards up, the normal stuff, your loopbacks, configure your interfaces, logging, alerting, monitoring, your DHCP, your authentication methods, decide upon your authentication methods, what you're going to do, and we're going to get into that a little bit later. Clock is important. You want to coordinate your logs, what's going on. It helps you troubleshoot things. And I'm going to reference a little model system here. It's just tiny, but then I'm going to show you some output from just a little bit of output from an actual our production system as we go along. And so what it is, I threw this together, and I was going to use the Visio, the things, but I said, nah, you know what? I'm going to use the little hexagons and stuff and pentagons and things like that instead of the router symbol. So you basically, the assumption is we're going to start with a working, we've got a connected little wireless network here. We've got this is all RB800s. This is the hardware, R52HNs or our cards. We got 3 sites. They represent towers, and you got an egress router down here, RX. That actually showed up better than I thought it would. And on the towers, you got 3 APs. Each tower has 3 APs bridged in. And then we're going to walk, from there we're going to go. One of the first things, you're going to set up, you want connectivity. You want to be able to move your data around your network. Now I know, okay, it's all connected, and it's really small, but we're going to dynamically route our network. And we're going to secure our routing protocols. It's an important thing. I know most of these guys probably don't overlook things like that, but I know that I'm hoping this information goes out to the community in general, and they can learn and observe things like this. But router ID, generally speaking, your loopback. Why? Because, well, it doesn't go down. It's always up. It's stable. You know what you have. On your interface, MD5 authentication key, and no SPF key is not the key that I use, just to make that clear. The point-to-point links you saw, they were point-to-point links. Why? Do you want to run an election process? DR, BDR, don't be shaking your head and grinning at me like that. You don't want to hold an election process, when you don't have to. It just makes your convergence better. Things are smoother. Point-to-point links is a point-to-point link. But I'll go through, and you see area backbone. I add my networks. I want to advertise my loopback because I want my network to know where my loopbacks are from my router, so I can reach them. Because we're going to use them. We're going to use them not just for this. We're going to use them for our for signaling, for our BGP, for the VPLS tunnels. And this is basically, I just go through the configurations on those hardware platforms. Now this is an actual output, an OSPF neighbor printout from one of our sites, one of our towers. And you see your convergence and the uptime, 8 weeks, 2 weeks on the other link. And that was Hilliard, yeah. Okay, it was power. But, and that's it for OSPF and OSPF authentication. Now we want to build in and start adding our MPLS over our network. We have our layer 3 reachability. Everybody knows where everybody's at. And now we want our MPLS on top of that. Now here's a tip, and I want to shout out, is Tom here? It doesn't matter, he had a long night. But in Steve's class, INE class, and I thought this was an excellent tip, the label range. And we began our label range at 16,000, and we worked up from there, and they had a really good point of that, is that it allows you to, the label range below that for any future, like if you want to do some other kind of things with MPLS, and you're not just like blasting all your labels, and you don't have to affect your network, you can add this in. Your label switch router, your ID, use your loopback, transport address, again, your loopback address. And this would be on all the routers. That's what I noted there. On all the routers, you would do this. That would be a pretty common thing to all the routers. And on router X, which is not up there, but it's the one on the lower right, your interface, your MPLS interface. The MTUs I'm using is 1526. You would use an MTUs as required or as supported by the hardware that you put into play. Again, this kind of needs to be uniform. This needs to be uniform across the system. And another thing, a note, on your interfaces, any interface forwarding traffic on your MPLS network needs to be included in this configuration. It should be, and just for stability's sake and for the network to work well. Back below and then, now you're going to add your LDP interfaces. And like I said, this is where the interfaces that are any interfaces that are going to forward traffic. On this instance, it's Ethernet 2. That's going to be an egress router. Okay, on router 1, MPLS, again, the dynamic range is out there starting at 16,000. Your label distribution protocol set enabled, your switch router IDs, your loopback, your transports, your loopback. On this one, you have more interfaces that you're dealing with. There's a default interface in there that comes up, 1508. And I always change that to match all the others. You can't just, and I mean, this was me, and with any other earlier versions, because I was doing this back in the 5 series, I found that leaving that and just setting that default at 1526 wasn't adequate. You do need to add the interfaces in there and set the MPLS MTU on those interfaces. Don't just set the default and say, okay, I'm good. But I match them up. And then again, your LDP interfaces, you add the interfaces that are going to forward traffic, and you identify those in that configuration. Routers 2 and 3, we did the same thing. Those only have wireless interfaces, linking point to point, so those were included. And this is what we have now. Okay. We have an MPLS overlay at layer 2.5. We have a label switch path. We have our label swaps going on at our routers. And then we have the label pop down there at the RX, router X. And so now we got a nice plate on top of our layer 3 network to work with. And we're not digging into an IP header. We're just swapping a label. The traffic knows where it's going. And here's what that's going to look like from another tower. I live in LDP neighbor, and I'm seeing the towers, the loopback addresses, the adjacent towers. they're not really x.x, they're actual numbers. And then remote bindings, I did a remote binding print, so you can see, and by that next hop, you can see the direction that your data is actually choosing to flow down that label switch path at this time. You see your next hop is a .197, and the peer, you can see is 128, and this last one down there, the actual direction to that destination was on a different tower, on a different label path, and it's reflected, and you see your label values down there. Local bindings, implicit null. Anybody know what implicit null is, except for Greg? What does that represent? It's a label pop. It's a label pop. You have explicit and implicit. Why is that a label pop? You're saying, oh, that's on the tower, because that's the loopback address of that tower that this is printed from. The other ones, you see the label, you see the peers, and you see two listed because it has an optional path, and the one down there, the label's not appearing on. If this path fails, you're going to see the label appear on the other, and it'll flow that way. And it's pretty much instantly. I mean, if you fail, it's gone. I'm going to use BGP to signal reachability for the VPLS tunnels, because I don't know, I didn't like static tunnel configurations at all, and they didn't seem to scale very well. They don't, and the BGP was just way better and a lot easier. And I know this is it's like a little 3-tower system, but R2, I'm using the default instance because I was lazy and I didn't feel like doing anything else. So the default instance, set the router ID. I set the router ID on these. It'll work if you don't set the router ID, but I set is the loopback, and this loopback reflects the loopback of the little model. And the yes on client reflection will pretty much be set by default. Routing BGP peer set address families layer 2 VPN. The name, you name it. On this instance, I'm calling it R2 to R1 peer. And the reason why, you'll see why it's going to R1 directly. And the remote address, 111, 1 is the R1 loopback address. And then likewise on tower, R3, I'm doing the same thing. And then on RX, the end router, I'm basically doing the same thing. I'm setting the peer address as 1111. And the reason why is because I'm going to make R1, it's going to be my reflector. And because I didn't feel like peer and everything else, it's sort of the same reason I used the default, the AS. And so I said, well, that way we're only having to peer with this one, and they don't have to peer with all of the routers. And on there, I said routing BGP instance, said router ID is the loopback address of the router, client-to-client reflection, yes. Routing BGP peer, set address families layer 2 VPN, name R1, R2 peer, remote address, and then the remote address is the loopback address of that one. You go to the next router, and the next router, now I have all my routers. And if you do print, this is from a route reflector, the routing BGP peer print, you're going to see established instances, the loopback address of the remote address, that default ADS. I noted that the 107, that's another reflector, because I do peer my reflectors together for additional redundancy. And then it goes on. It's so long a list, and I didn't want to burn up 3 slides with. So, and then output from a tower. As a tower would see it, he's peered with 2 reflectors. And you'll see in a little bit the slide when I show the system is why we have regionally distributed route reflectors, because there is the possibility that you could have a catastrophic power outage or something over here and then lose. And I don't want to take my own system down because I lose that. So I have them geographically distributed across this system. And if I do a printout from a peer doing a detail print, you can see the name of the site, the instance, use default remote address. Again, the MD5 key, I put those on. Also on my BGP So the peer settings, so I have an MD5 key setting on those as well, and it's not BGP key. And I did a print from there, and it shows the two peers and key. And so now we'll walk on to set up a VPLS tunnel, because we have the ability to know, the VPLS is going to be signaled. You could do it the other way around. You could set the VPLS up and then set the BGP, but it's kind of cool to see to do this tunnel, and as soon as you hit boom, you see the thing go RDB, and it pops up. So on router X, this is going to be, I'm going to call it a concentrator. This is where this is where they're going to terminate to go out onto layer 3. I'm adding a bridge, the name of that local bridge is adding to that. Cost of 0, horizon values. Now, a quick talk on that. Horizon value is spanning tree. Spanning tree, y'all know what the spanning tree does. I'll go into spanning tree. Horizon, split horizon, think split horizon. Data doesn't go back up the path that was learned down. And you can use horizon values on your bridge. And you notice I had 3 APs on a bridge. We ran into some peculiar instance where we had a client to an AP to fill in null areas and some tractor enclosures and sheds. And what it would do is it would cause some topology change notifications to occur every now and then. And I saw this happen on the bridge. I said, "Pings, what's going on?" So I checked it out and realized that. And I thought, man, okay. I have an option here. I can go in here and I can just configure spanning tree on the system, and I'm going to have to continue to configure spanning tree. And then if I add and make changes and do things and moves and stuff, I'm going to continue to have to configure spanning tree. Or I can use horizon values, because it's one of them path of least resistance. And it works. It establishes very firmly the way data's going to flow and where it's going to go. And it doesn't really consume anything because it's not making any calculations. It's just a setting. So I went with horizon values, and it works like a champ. And so that's why it's represented in here. And again, horizon values, y'all know, that's only unique to the bridge that it's on. It doesn't transport across the network. Router over there doesn't know anything about the horizon value on this router right here. The horizon values do matter locally. So if you set everything, as you would see, if everything was set to horizon value 3, well, you're just kind of not going to go anywhere. But if you notice before, the horizon values that were set on towers, which I'll point that out in a minute, they're 1. The tunnels on this one are 3. They don't have to be 3. They could be 2 or 1, but they're 3. And then VPLS tunnel value is a 2 on the tower, because that's where my stuff's got to go. And anyway, so I'm identifying all my, on this concentrator, what I'm going to call a concentrator, at my router X. There's my towers, R1, R2, and R3. Site IDs have to be unique to each tower site, and that's well documented. MPLS, VPLS documentation, that's important. The route distinguishers, import, export. You can do this 2 ways. You can mesh it where they're all aware, and if you look at the tower and you do a printout, you're going to see all your VPLS tunnels. You're going to see them on every tower. I didn't know, and I didn't really notice any kind of a difference in performance, good or bad. What I did notice is when I did have them meshed that way is, you'll see this bump of broadcast traffic, bump, every now and then, but I would see it on all the towers, and I thought, well, do I really want to see that, or do I need to see that? No. So I went with a more of a point-to-point approach, which we'll talk about that again in a minute, with my VPLS tunnels. And so the route distinguishers, import, export, are unique to each tunnel. And all right, so, and then I go down the router 1, the tower bridge, and the VPLS is the name of it. It's the VPLS R12 RX. The route distinguisher 11, which is the same as it is up there for R1 on the concentrator bridge. And then the import, export. And there's the horizon value 2, which gives it the ability to move data through that interface. And likewise on tower 2 and tower 3, you're going to do the same thing. And here's a printout from an actual, production site, running dynamic BGP signal, your VPLS number, the remote peer, and then the actual VPLS bridge identified over there on the right. And then from a tower, a printout interface, VPLS, BGP VPLS print, and you see the route distinguisher identified and then the bridge name that it's coming off of. And this is what we've evolved to now. We have a layer 3, we have a layer 2.5, and then we have VPLS. And I drew the straight lines. I didn't feel like driving curved lines because I was messing them all up and they were looking weird. So I went with the straight lines. It's representative, and it would happen. Now here, on the towers, you see H1, you can see, yes, you can see that. H1, H1, H1. H2 gives me the ability to move data off of there. The H3 down there, which is, again, only local and matters only locally to that bridge. But do you have redundancy on those VPLS tunnels? Are they, like, redundant? What happens? Is there a possibility something goes on? What happens if I blow out that link over there between? Because I'm assuming, I'm just not without, because we can't print this out, that the label switch path from this tower over here, R2, is going to be through R1 to RX like this. So what if I happen to lose that link? I've got layer 2.5, it's going to reconform immediately like nothing, just like that. And it's going to go this way. So yeah, it's a point to point, but because of MPLS, it's redundant, and it will reform around another path. Now here's a few tips. This doesn't have nothing to do with MPLS necessarily, but ACL's access control list of management protocols, not a bad idea. If you have management network that you use and management VLAN or specific addresses that you only want to connect your devices from, there you go. And you set these commands. Print it out, service any unnecessary services that you don't need. On this particular bridge, I do not need FTP, but we do use FTP. I'll get to that in a minute. How's my time? Close. Okay, I'm gonna speed it up. Again, NTP, time is important for logging purposes, for coordinating, for troubleshooting. It helps you out. I use email. I have a log setting, action. If you log into my router, you log out of my router, it's going to send me an email. I'm going to know that you did it. And this is basically what you do. Set a privilege level on groups. Have certain groups you want to manage. Do you necessarily need to log in with full access, full privilege? No, you don't. And especially if you have other people logging in, you really want to consider having limited privilege groups for access. I actually use Radius server. I use Cisco ACS. We've got the Mikrotik libraries loaded in there. And to authenticate, you can authenticate login, and we also use it on, or I'll get into that in a second. But if you do use it for your wireless, there's a little tidbit down there. So what you're going to want to add to your security protocol. Authentication, yes. I use accounting too, yes. Very helpful troubleshooting tool. Here's a little bit of log output. Just some spreadsheet log output. You can see authentication okay. That top one there, that's a tractor. The 0020, that's what we use is, we call them a hobo link. They're like a weather station. Actually, that could be a weather station or a fuel station because they use the same product, the card on them. And then in the bottom, you see somebody with their laptop, it looks like, and I don't know what the other thing is, a phone. They're not authorized, so they're not connecting. Because, as you all know, a shared key is only secure until you share it. And then you have to assume it's not secure anymore. And the clients on the tractors and stuff, they were not that sophisticated, so we used WPA2 pre-shared key. But as you all know, as people get accustomed to each other and used to each other, they're going to share this key. And that was evidence of that, what you saw in that bottom of those failed attempts was some, hey man, it sure would be nice to check my email or get on there, I want to do some Facebook stuff or whatever. And it denies them access, even though they have the pre-shared key. They can't get on, they can't get a DHCP address, and they can't run. And this here's, again, it's a script we run. It's a script that runs on there that it basically every minute it collects the Wi-Fi stats and it prints them to a file throughout the day. And that's where I get back to the FTP. We use it on the towers because we grab that off the towers and we import it into this application that was developed in-house, and a big ups to Kenny Light, the application developer that did this. We combine this with the telematics data from the tractors that provide GPS location and then information that they have, and it renders it into this application that shows these data points throughout the system and the jobs. And it's kind of cool because through the day you can hover one of those data points, and this is one of those data points hovered right there, and this is the kind of output that you're going to get. The tower that it's associated with, the range from the tower, the top of unit, various other bits of information, client connection quality. We saw this is pulled from the stats. The telematics delay, and I'll show you, like when you see some of these yellows down here and then some red, that telematics delay plays a large part about. That's actually transporting that little data file that it sends to Colorado. Right now is where it was going, and it measures delay in seconds on that, and if it's like having trouble getting out there to Colorado, it'll cause that color change. And then the equipment speed and various other things. You can zoom in on it and you can actually see, it's like playing Farmville sort of, and you can see the progress of a job. You can see, and those aren't necessarily one tractor. You'll have multiple tractors in the field, and you got a red guy down there, you say, well, these guys are green, why's that guy red? He may be having a problem with an antenna or who knows what, but it gives you, so you can go investigate that unit. It's not just you're troubleshooting your system, you're troubleshooting like sorry about that, and endpoints in time. And the great thing about this is over time, you're actually kind of building a living coverage map. And so next year, you can do comparisons and say, everything was so green in here this year, it's more yellow now, and chartreuse, maybe a little paisley. I was trying to get you to laugh. But you can see if there's degradation. But if it's uniform degradation, you can start to say, or else if you wind up in areas where it's all red all of a sudden, it's a helpful tool. It's good stuff. Anyway, this is kind of like a high-level view of the system. I know that's a lousy kind of underlay map on there, and that is a lake, believe it or not, but that shows the kind of the towers and cells. And to perspective, this is an actual, it's sized and scaled down to fit, and that's the footprint on the state of Florida and of how big the system is. And this is just a look at some of the build, the site makeups. We've got some 50-footers, so solar powered, where we don't have line power, 120-foot self-supporting. That's the one up on the upper right, and then that's another 50-footer down there. And there's a couple form factors we actually used when we built this. This is one of them that we're kind of getting away from, that I used RB800, and I used a 433H below for the point-to-points. And then you see the sectors and how they're bridged in. And this is kind of the model that we've gone to. And this was already in the original build, but it's also the one that we've basically adopted. And it works great. For the kind of data that we're using, the boards perform like a champ. Reference material, again, I know it's not inclusive because I'd have to have 2 more slides to get all that included in there. And I know everybody's really kind of hungry. So I know I am after last night, and my stomach's really growling. I'm surprised it's not picking up on this mic. But if you'd like to get with me after this presentation, and I'd be glad to talk at length about anything about this, and even give you copies of this, for you to take. And all right, and that's our office and our seat tandem and stuff. And I thank you very, very much for listening to me.